you're watching me from, this is your favorite tutor, Yomi Omorewa. And in case you're new to my channel, Payseta Tutorial, you can just subscribe to my channel and also click the notification bell so that whenever I upload any new video, you would be notified and then you'll be enjoying whatever I'm uploading on my channel. And so this very morning in this part of the world, I'll be taking you on a journey of trigonometry. Trigonometry. Actually, I'm still going to take algebra later, and I'm still going to take calculus as well. And so for now, I'm teaching on trigonometry. Trigonometry. I have to do trigonometry because I know that the knowledge is needed. So trigonometry identity. Oh, I wrote trigonometry. So that's what we're looking at, trigonometry identities. So you can see what we have there. The first thing I like to do very quickly as I introduce you to this topic is to derive some basic formula that you need to know. So I'll start by doing this. I'll call this A. I'm going to call this C and I'll call this B. Obviously, this angle is B. What will happen to this? Okay, this is going to be the side B. It's going to be side C and it's going to be side A. So if you have something like this, I assume this is your right angle triangle. And I want to take that, okay, your right angle triangle, as I want to put it here. Now, so from what I have here, I'm going to employ the knowledge of SOHCAHTOA. SOHCAHTOA means the x there is sine is opposite over hypotenuse. The car is cosine adjacent over hypotenuse, and the tour there is tangent opposite over adjacent. And let's demonstrate that quickly here. So you have this now. So we have sine theta, that's B, over C, that is opposite over hypotenuse. That's for sine theta. So this is your hypotenuse, please take note. This is your opposite side, take note. And this is your adjacent side, take note as well. And so we come to our cosine. Our cosine is adjacent, which is your A, over hypotenuse, which is your C. I'm sure that's very clear. Then come to our tangent, which is tan theta. So we have our opposite, which is B, over adjacent, which is A. And this is so important for you to note. And for those who probably did further mathematics in secondary school, I'm sure you remember something like tan, something like cotangent, something like sec, and something like cosec. And so you have sec. Sec is 1 over cos. Sec is 1 over cos. And if you are to employ what we have here, it's going to be 1 over what now? A over C. The reciprocal is C over A. Now you do the same thing with cosec. My cosec theta now is 1 over sine theta, which is 1 over, what is sine theta? Sine theta is B over C, which is C over B. And then we come to cotangent. which is cot. Cot is actually 1 over what? 1 over what? Over tan theta. That's right. So it means that I have cot 1 over what's your tan theta? B over A. So cot theta here is what now? A over B. Now it's important to know this, that our tan theta is equals to sin theta over cos theta. It's very important. If you want me to prove it to you, let me prove it in a simple way. You ask yourself, what is sin theta? A sin theta is B over C and then divided, that's division sign. What's cos theta? A over C. So B over C multiplied by C over A. You divide, so that gives you B over A. And then you want to ask, what exactly did we have before? We had B over A, and that was what I got here to tell you that your tan theta is what? Sin theta over cos theta. Similarly, we can also say that our cot theta is cos theta over sin theta. Yes, that's correct. Now, if I do the same thing, so let me just prove it to you again. So what's cos theta? Cos theta there is A over C divided by what's sin theta? B over C. So my cot theta is A over C multiplied by C over B. And then you have cot theta, which is this, cancel this, A over B. And that's exactly what we are having here. Cot theta is A over B. I'm sure that's very clear enough. Okay, that's clear enough. Now, the next thing I'd like you to note carefully is the fact that I want to use Pythagoras theorem. You know what we call Pythagoras theorem? Pythagoras theorem says that the square of the hypotenuse means the longest side, is equals to the sum of the two other sides. That is Pythagoras theorem. Pythagoras. By Pythagoras theorem, we have hypotenuse square equals to opposite plus adjacent square. In other words, the square of the longest side is the sum of the two. What do we have in our longest side? We have C. What do we have in the opposite? The opposite is B. And what do we have in our adjacent? And we have A there. Thank you. Okay, so if you see this now, let me do something. Divide both sides by C square. So you have C square divided by C square, B square divided by C square, A square divided by C square. C square divided by C square, what do you have there? 1. The question is B over C. Let's go back to where I started from. B over C is sin theta. So you have sin square theta because we're having square here. And then come here. Please do take note that B over C this and this implies the same thing. So B A over C is what? Cos. So you have this. This is called fundamental. This is called fundamental identity. You see, I always like teaching, I always like looking at trigonometry before venturing into calculus. I mean, differentiation and the rest. The reason is because if I'm solving, there are questions I'll be solving in calculus. I might need the knowledge. Not I will need the knowledge of trigonometry to navigate properly. And this is why I always like students to master trig to a large extent before they venture into calculus. So you can see now that how I derived the sine square theta plus cos square theta, how it became 1. Now we can also get further identity from there. We can get further identity from the fundamental identity. We can get other identity. For example, so we say that sine squared theta plus cos squared theta is equals to 1. And I'm calling that my equation 1 actually. So I can say divide equation 1 by sine squared theta. So I'm going to have this. So when you divide this by this, what do you have? You have 1. I'd already established, and I thank God I did that. I'd already established that cos over sine is what? Is cos. So that helps me to be able to navigate properly. So this over this is cos. And I'd already said that 1 over sine is cosec. So we have cosec square. This is my equation 2. This is another identity that should be noted, that 1 plus cos square theta is equals to cosec square theta. Similarly, divide equation 1 by cos square theta. So you have this. So now that sine over cos is what? Is tan. So I'm having tan here. Cos over cos is 1. And 1 over cos, I'd also established that it is sec. So you have sec squared theta. This is my equation 3. Now, I have been able to derive 3 identities that you may need. And I like to solve 1 or 2 questions from here. I like to solve 1 or 2 questions from here so that you could see the application of this. So I'll pick questions online and just solve. Okay. So I'll pick question online and we might just have to solve. So I'll put some questions on the board and then we have to solve the question very quickly so as to see the application, because you might be wondering what's the use of this. Okay, so let me put 1 or 2 questions on the board. Yes, here are questions. Let me call it class work. I'm going to do it myself. Simplify. So you have here, I'm actually getting question online. Multiply by cos squared theta. And then number 2, we're told to simplify 1 over cos squared theta minus tan squared theta. And then, so we want to look at this now carefully. Looking at these 2 questions is quite simple. So we can do something, solution. So to solve this question, we know that stands what? Tan square multiplied by cos theta. Now look at this now. We know, what do we know about tan? We know that tan is this over what? Over this. And then here you have this here. You can cancel this. Yeah, that's allowed. And then you are left with this. You cannot further simplify what we have this. So this becomes the final answer. You cannot further simplify it because the question says we should simplify. Number two, we have 1 Okay. Now, I might not even need to do this way. So what I'll do is that I'll say this now, and then what's tan? We just did tan now, and we saw it. So over this. So I could just find SCM. What's XCM here? The SCM is cos square theta. So cos square theta and cos square theta is 1. 1 times 1, 1. This and this, what do you have? 1. 1 times sine square theta, sine square theta. Okay, now, do not forget that we said recall that sine square theta plus cos square theta is 1. Do not forget that cos square theta therefore will be 1 minus sine square theta. And so anywhere I say cos square theta or anywhere I say 1 minus what? Sine square theta, I could put what? I could put what? Cos square theta. And that's exactly what I'm having here. What I have here is 1 minus cos square theta. And so I would simply put, in place of 1 minus cos square theta, I will put cos square theta. And our denominator is also cos square theta. And the final answer is 1. This is the application of the identity. But I'd like to solve more questions, maybe one more questions or two before I leave the identity. So you appreciate the application. Let me get one more question or two from online. So here we are told to prove. We are told to prove that one minus sine alpha over cos alpha is equal cos alpha over 1 plus sine alpha. Maybe there are still more questions, so I might have to get, okay, let me stop here. Now, looking at this question, now to prove, there are 4 ways to show that your equation have been proved. This is so important for a student to note. There are 4 ways to show that you have proved equation have been proved. Rather, number 1, if I pick the left hand and I solve and I get the right hand, it shows that I've proved the question. If I pick the left hand, the right hand, and I solve and I get what is at the left, I've proved the question. If I pick this now and I minus this from this and I'm getting 0, I've proved the question. If I pick this and I use it dividing the and I solve and I get unity that is 1, I have proved the question. I've just mentioned 4 ways now. Number 1, pick this, you get this, pick this, you get this, or pick this, minus this, you get 0, or pick this, divide this by this, you get 1, you have proved the question. Which one is easier now? I think I have to look at the one that because you are not trying to prove any point, you want to go for the easiest method that will help you arrive at your destination. So I'm going to go for this. I'll say from my left hand side. For my left hand side, I have this minus this over cos what? Alpha. What do? That's what we call rationalization in mathematics, in sort to be precise. So I'm going to rationalize the numerator using the conjugate. So I will have this. So that's what I'm going to do, the conjugate. So if this was to be plus, then I would have used minus on both sides. But because it's minus, I'm using plus. So we can now multiply. Let's assume that there are those who are online, who are not following, who do not have a background at all in this. So I'm going to be systematic about it. 1 times 1, so I'm having 1. 1 times sine theta, I'm going to have, sine alpha rather. This times this, I'm going to have sine alpha. And then this times this, I'm going to have minus, that's minus times plus. and sine times sine alpha multiplied by sine alpha. That's what you have. Then this times 1, you're going to have that. And then this times this, you're going to have sine alpha and cos alpha. Okay, so now for what we have here, now you know that this will cancel this. Obviously, you know that. So we have this now minus what? Sine square alpha over what? Over what? What do you have there? Cos alpha plus what? Cos alpha sine alpha. Thank you. Now, do not forget, we just did it a while ago. What we have here, we say cos square theta minus equals to 1 minus sine square theta. So it means that 1 minus alpha square can be what? Cos what? Cos alpha square. Cos alpha square. Cos alpha square. And so here we have cos alpha plus what? Cos alpha sine alpha. Please do not forget that. So I'm being systematic about it, and I'm sure you're following. Okay. All right. So let's go. I guess you're following. Okay. Now you have cos alpha over cos alpha cos alpha sine alpha. Okay, so this is cos alpha base. Now cos is actually factorize it. I shouldn't have even bothered myself to do that the other time. So you have this now back. So I just simply factorize it. So this one of these we go to cancel this, and so you have this. You're left with alpha, and this we go. So you have cos alpha over 1 plus what? Sine alpha. Proved. That's exactly what we have here, and case closed. You understand that now? So we got that carefully. So we have been able to prove that question, and that shows that we have solved the question. So that's trigonometry identity that we just look at now. Now, I'd like to do one more aspect of this, and that is addition formulae, and I'll also do multiple formulae before I close the trigonometry class. Addition formulae, and subtraction formulae. So I'm going straight to it. So addition and subtraction formulae. Or let me use the word formula now. Formula is plural, formula is singular. Okay, so look at it now. So we have sine bracket A plus B. This will give you sine A cos B plus cos A sine what? Sine B. Come to the minus now. You have this. Look at the pattern again. This will give you the pattern. So this is the pattern. It will go this way. And then you have cos bracket A. You're going to have it the other way around. So it will be cos A cos B. Now minus this time sine A sine B. You see now this minus when it's plus here. Very important. Of course, you should know that sine and cosine are not the same at all. As a matter of fact, there is what we call odd function and even function. Cos is an even function, and sine is an odd function. So you do not expect them to exhibit the same property at all. So you have this now. So this is plus sine A and sine what? Sine B. Okay. So we do that of tan. Tan is tan A, tan B, and tan A, tan B. And then if you come to the minus part, you have tan A minus tan B, 1 plus tan A tan B. That's what you have. This is called addition formula. Now, another question. What's all this for? What's the application? Let's look at it quickly. Application. You know, it's important you know application of something. Why is that thing given? Why do we have it? So let's see the application quickly. Look at this question, for example. You are asked to evaluate without using tables or calculator. You are asked to evaluate without using table. And here is the question 1. 15 degree. 2. 3. Here you are with this. And you want to evaluate it without using table or without using 4-figure table or any of those or calculator. Thank you. How do you go about it? Now, to do this, you need to first understand what we call ratio or special angle. A topic called ratio or special angle. For our friends who are watching in any part of the world, it's been very hot in this part of the world for some days now. And so you see me just touching my body and touching myself. We hope that the heat will subside a little soon. Now, if you look at this now, you need to know the ratio of special angle. What are special angle? Angles like 60, angles like 45, and 30 degree. These are the special angles. Okay, for our friends who are watching, let's try to recap. Let's try to recall rather. Let's try to do some play here. Let's go. Sin 30, what is it? 1/2, right? Yes, you are correct. If you are saying that when you're watching. Sin 60, what is it? Root 3/2. You are correct. If you are saying that, that's 0.8606, that double 60. You're correct. And then if you're saying, okay, tan 30, what's that? Root 3/3. Okay, you understand that now? You are correct if you're saying that. Actually, it's 1/3, but we say that it's root 3/3. I don't want to prove that because I'm not teaching that now. Then come to cos. What sin 60 will give you is what cos 30 will give you. And what sin 30 will give you is what cos 60 will give you. And then come to tan 30, tan 60, that's root 3, which is 1.73 thereabouts. Okay, then you come to 45 now. Sin 45 is 1/2, which is 0.7071, or what you call root 2/2. And cos 45 is the same as sin 45. They give you exactly the same thing. And then tan 45 is 1. Tan 45 is what? Is 1. So let's look at it now. And this is what we are using. We're using ratio of special angle. So to do this, I'm going to have tan 15. Remember, I'm telling you application of this. Okay, so you have tan 45, which will give you this minus 30. You get that now? What does this mean? This is tan 15. And tan 15 implies that you are multiplying, you are removing 30 from 45. That gives you 15. Am I correct? Exactly. That gives you 15. So it's 15 you are having there. And so from here, we say that you have tan 45 degree. We're using this now. No, we're using this. We're using this. So we're using this. So 13 degree over 1 plus what? Tan 45 and what? Tan 30. I'm sure that's very clear. If you're watching, you know that this is very clear enough, because my tan A here is 45 and my tan B here is tan 30. You can see it now very clear. So A is 45 and B is 30. So let's go now. What did I say is tan 45? 1. What's tan 30? What did I say about it? Root 3. What did I say about this? So you have 1 This is also 1. 1 times this, so it will still give you root 3 over 3. Actually, tan 45 is 1. 1 multiplied by the gives you the same thing. So you find the SCM of the numerator, root 3. Just do like this. SCM of numerator is 3. 1 in 3. 3. 3 times this one. You have it here. And then 3 in 3, 1. 1 times root 3. You have it there. Divided by, divided, that's this line. So you come here, division, that's this. Then SCM again, find the SCM, 3 in 3. What do you have there? Eh? Remember this in this. Okay, so you have 3, thank you. And then 3 in 3, 1. 1 times root 3, root 3. So this will give you now 3 root 3 over 3 multiplied by what? Over 3 plus root what? 3. Thank you. Cancel, cancel. So you have what? 3 root 3 over what? 3 plus, okay. So what do you do? Do you leave answer like this? No. What do? You rationalize the denominator. So it gives you root over root 3. Thank you. So 3 times 3, what do you have? 9. 3 times this, that's 3 root what? 3. This times this, what do you have? 3 root what? 3. Minus times minus plus root 3 times root 3, that's root 9. Come down, 3 times 3, 9. This times this, 3 root what? 3. This times this plus 3 root 3. This times this minus, and then you also have root 9. So let's move here. It's interesting, and I believe my friends online, students online, you are following in a systematic way, just as I'm doing it in a systematic way. All right, so you have 9 minus root 3 minus root 3. It gives you minus 6 root 3. That's important for you to note. Root 9 is 3. Some students might say something else if they say something like that. So please take note. This will cancel what? This. So you are left with this, this. So 9, 6 root 3. So we collect like 10. So we have this. This plus this, that's 12. That's 6 root 3 over 6. What do you do here? Factorize 2 root 3 over 6. Cancel, cancel. Our final answer, 2 what? Root 3. So you can see where we're coming from. So that's the application. The question will say without using calculator or table. So you have to go through all of that. That's the application. I'm sure that's quite clear. If I were to ask my friends online to do this for me, I'm sure you will do it. Ahead. Okay. So I'm sure you will do it. So you're going to do it. I'm not going to stay too long on this. I won't even solve it. If I was to do this now, what would I have done? 105, what does it mean? It means cos what? 45 plus what? Plus 60. Maybe I should just do it. Let me just do it. I'll give you this to do. Okay, 45. So I'll go to that. I'll say cos 45 degree and cos what? 60. Since it's plus, it will be minus here. Sine 45 and okay. So friends, that's addition and subtraction formulae I was talking about. The last one, quickly, because of limited of time, is the multiple formulae. I'll stop at multiple formulae. I'll stop at multiple formulae. Quickly, multiple formulae is similar to let me use formulae. Now, Multiple formula is very essential too because I'll just go straight to the point. A situation where you have A plus B, it will not be so. You'll be having the same thing. So let's go. Evaluate the following. 1. Sine 2x. 2. Cos 2x. 3. Sine 3x. I'm not going to do everything. Yes. So I'll give our friends online to do it. So I could continue like that, 4, 5, and the rest. But let me stop here. So solution, sine 2x. Excuse me. Now, sine 2x is the same thing as x plus x. Can you see now? So you're going to make use of the knowledge of addition formula, which is sine x, cos x, and cos x, what? Sine x. By the time you do this carefully, you have 2 sine x cos x. That's that. That's all. Similarly, come to this cos 2x. Again, still remember, we have to do it this way. And this is what now? Cos s from our addition formula, it will be minus because it's plus here. So sine x, what? Sine x. And by the time you do that carefully, you have 2 this, you have square this. So in this case now, you have to recall sine square s plus cos square x is 1. So you have to recall that. So recall that. So if you have sine square x to be 1 cos square x, it means that your cos square x minus sine square x, what will happen? What will happen to it? Look at it now. So in place of this, put this. So you have cos square x in bracket 1 cos square x. So we have cos square x 1 plus cos square x. Add these two together, you have 2 cos square x minus 1. That gives you cos what? 2x. So if you do it the other way around, cos 2x will give you 1 minus sine square x. So it means that cos 2x has 3 answers. Number 1, it can either be this. Number 2, it can either be this. Number 3, it can either be this. That's cos 2x. Very important. That takes me to tan 2x. So tan 2x now, therefore, is x plus x. So you have tan x, which is 2 tan x. Oh, sorry. Which is 2 what? Tan x and 1 tan square x. So this is the answer to this. Very straightforward as well. Now, where I would like to explain to our friends, all of these are simple. In the university, you see that you might be asked to find something like sine 3x and not 2. To do this will become sine x plus 2x. So when you open it up, you have something like this. When you open it up, you have something. This is where the work is. But thank God, I've been able to simplify. I started with all these two. So it's easy for us. So we just say sine x. Since I am solving sine, all my answer must be left in sine. So for cos 2x, what is cos 2x in terms of sine? It is 1 minus 2 sine square x. Good. This is cos 2x. And then ask yourself, what is sine 2x? Sine 2x is 2 sine x, what? Cos x. It's still in my head. So open the bracket, you have sine x, and then come here, you have 2 sine cube x. By the time you multiply this, what will you have now? 2 sine x, what? Cos square x. So you have sine x, 2 cos cube x, 2 sine x. What is cos square x? Is 1 minus what? Sine square x. Know that. So we have this 2 cos cube x plus 2 sine x minus 2 cos cube x. So by the time you bring everything together, so you have this plus this. So this will give you 3 sine x minus 4 sine cube x. So for our friends online, you can do the rest. You can do the rest. So this is where I'm going to stop because of time. Where I'm going to stop trigonometry today. Watch out for the next class, which is calculus. So I will no longer be doing algebra today because time is a little bit not on my side. Thank you so much for watching the video and following up online. Till I come your way again, I remain my humble self, Yomi Omorewa. Bye.